Hello, I have a problem. My problem is one of translating virtual addresses into physical addresses. The system in question is Linux version 4.9, and it's running the architecture AArch64. I need to convert these virtual addresses into physical addresses because I'm doing memory introspection. Memory introspection is when one system looks at the complete physical memory range of another system and makes some forensic judgments about it. The judgment I want to make in particular is about the kernel modules that are loaded into the Linux kernel. I want to know what modules are loaded, I want to know what their names are, and I want a hash of their read-only data. And I want this to be able to ensure that the system I'm introspecting on is behaving as it should be. In other words, it's for the purpose of intrusion detection. I know from the ARM64 developer's manual that translation tables are used to translate virtual addresses into physical addresses. The procedure by which a virtual address is converted into a physical address is called a translation table walk. A translation table walk is a sequence of lookups in one or more translation tables. When a system begins the translation table walk, it doesn't know how many lookups will be required. What is required for a translation table walk is a virtual address and the base address of the translation table. Fortunately, with some help from the volatility community, I have the base address for the translation table for my system. Here's why I believe I have the base address of my translation table. During the compilation of the Linux kernel upon which I'm introspecting, a file is outputted and it's called system.map. System.map is a big dictionary that maps addresses to symbol names. In my system.map file, there's a symbol called swapper underscore pg underscore dir, dir dir. I understand from the volatility community that this swapper pg dir symbol points to the first level translation table. Now, I've also learned some things about the translation table from the ARM64 developer's manual. I know that a translation table lookup is treated as one 64-byte read. And I know that for the purposes of table lookup, the table entries are considered to be 64-byte objects. So I understand I should be able to index the translation table as 64-byte objects. So that's why I think I have the translation table, and there's also one additional fact I needed to know about translation before I continued. I know that virtual addresses are split up into two parts. The lowest order bits are the offset into the page, and the upper order bits are the index of the page, or is sort of the address of the page. So the way a virtual address gets split up depends on the page size. I know in my system the page size is 4 kilobytes. I know this because the command getconf page size returns 4096. In order to provide an offset into a page of size 4096, I need to provide 12 bits of offset. Thus, equipped with this information about address translation, I begin to do some forensic analysis on my system. There's an address I have, and it looks like 7C2188. This address points to one kernel module in a linked list of kernel modules. So I know that the address gets split in half, where 188 is the offset into the page, and 7C2 is the index of the page. Now I can confirm this by a fingerprint search for the physical address of that kernel module. The physical address I found for that kernel module ends in 188. So I know that I should be able to use the translation table to translate 7C2 into the proper prefix for that physical address. However, I've not really had success doing that. My first guess was that I should treat the translation table as an array of 64-byte objects. Now, when I tried to investigate the 7C2th 64-byte object in this array, I came up with just zeros where I was expecting an address. Meeting with failure in the straightforward approach, I tried a different forensic analysis. Because I can do a fingerprint search for the kernel module in question, I can, at every run, determine the actual physical address. Now, it turned out that the prefix for the actual physical address always looked like 455 hex hex. So I said to myself I should be able to search for the hexes 455 in the translation table. By doing that, I hoped to find the proper entry in the translation table for that physical address. If I did that, I could find the offset for it in the translation table, and doing that, I should find 7C2, I hope. Unfortunately, all the ways I could think to search for 455 in the translation table turned up empty-handed, but there could be a problem with endianness. If my searches were well formed, however, the problem was likely that there was another translation table required. In that case, I believe the first lookup, the 7C2 lookup into this translation table, should return the base address for a second translation table. So this is the part where I'm stuck. Am I misinterpreting the endianness? Am I misinterpreting the virtual addresses? Am I misinterpreting the developer's manual? I'm not sure. Now, this is the part where I ask for help. If you see what I'm missing, please leave a comment. Okay, until next time, goodbye.